Hi everyone, I'm Manpan Wong. Today I would like to present my high performance building design project. My project is about a small hotel. Let me give you some overview on the base model. The hotel with 4 story, it is about 78 guest room and it includes the laundry, it includes the lunch and some fitness activity. It is located in Nanaimo, British Columbia, Canada. So the comfort zone is belong to Zone 5. According to NECB, the HVAC system for the hotel should be the system 1, that is the PTAC no baseboard. So here is the piping diagram. We did energy modeling and find out the breakdown. The natural gas take a large proportion on the energy consumption. And three major energy consumption customer will be the space heating, surface water heating, and also for the um, interior lighting. And the TUV will be 244.43 kilowatt hour per year per square meter. And the greenhouse gas index will be 37.87 kilogram per square meters. We analyze some high level measure and we reject some of them. Let's say the high performance glazing, because right now for our building the window and wall ratio is not very high, only 20%. So even we replace now is the double glazing to triple glazing, it didn't put much improvement on that, but we need to invest a lot. And second thing is about the lighting system. We know if we can do some daylight control, it will be helpful. But remember, our application is a hotel. So if we do the control first, we will think about the flexibility. And also, this also will affect the guest satisfaction on their using our hotel facility. Final one will be the solar system and solar technology. I know for some province or for some city, it may work, but it may not work in BC because we have a very wonderful renewable energy, the hydro. So we will not consider this as we also need to invest a lot. But compared with it generate the electricity and also with the power consumed by BC Hydro, it may not have a very big saving. So what we will consider first is about the building envelope. We will enhance the system and putting the quartz, the 100% natural and 100% or negative embodied energy material, that is a quartz. We put it in the, the exterior grading instead of the block. It provide a higher conductivity and I mean the lower conductivity and also a better insulation index. Second, we will rebuild the air sealing and make sure there's not to eliminate the energy loss through the convention. When we enhance the building envelope by the insulation and also the air sealing, ventilation is a must for us to consider. So we will install a heat recovery ventilator. First, it, in order to provide a fresh air and provide a healthy environment to the occupants. And second, we make use of the heat indoor and to do the recovery and hope we can have a lower energy consumption on the space heating. So our fourth approach the fourth measure is about to replace the gas boiler to the heat pump water heating system. And final one, as the interior lighting also take a very major consumption. So we try to replace the LED lighting. We put these five measures in the IES modeling. Let's see the result. It is about the quad grading. It's about the air sealing, the second measure, and about the HRV and also the heat pump water heating system. And it is the last measure of LED. In order to have a better picture on the energy saving and the greenhouse gas emission reduction, I have constructed a comparison table in the next page. So here is the comparison chart. The chart in blue color is the energy consumption intensity. It shows that five measures have the energy consumption reduction. And for HRV and heat pump water heating system, it can have much more saving in the energy consumption. And about the greenhouse gas emission, it appears as the orange chart. We can see for hot grading, air sealing, HRV, and heat pump water heating system, it shows the reduction and the saving, but not for LED. Now let's look about the financial analysis. It is the cost grading. We need to have 34 years to pay back, and it is about $9,000 to save a tons of carbon dioxide emission. For the air sealing, it takes longer payback time, it's over 100 years, and costs more to save the tons of carbon dioxide. For the HRV, so a very good result. We only have to take 3 years to get the payback, and we only spend 1,200 to save the tons of carbon dioxide emission. For the heat pump water heating system, it takes longer but not too bad, 6 years to get the payback, and spend around 2,000 to save tons of carbon dioxide. And for the LED, it shows a negative number, so it won't get help on the financially on the payback and also the greenhouse gas emission saving. So among these five measures, HRV show the best result. It obtained the shortest simple payback value and also the lowest incremental capital cost per greenhouse gas saving. About the scenario selection and analysis. Now we put four scenarios. The first one is the minimum department standard. The second one is the cost natural design that mostly consider the capital cost and the lower simple payback period. The third one is the maximum greenhouse gas reduction. The final one will be the optimum hybrid design. So in every scenario, we also consider the five measures we did previously. And for the scenario one, we will consider the HRV, and we take away the heat pump water heating system, as we only fulfill 24% energy saving. And for scenario two, we only consider the capital investment. So we will consider the quad grading is we do not need to spend too much, and also the HRV. We also don't need to spend too much. It's about $70,000 per each measure. So I would say is not a very high amount. And the first scenario, we only focus on the greenhouse gas emission reduction. So we are not no longer consider the cost. So I will consider the HRV replacement and also the heat pump water heating system, because they both show a very excellent result in the greenhouse gas saving reduction. And the final one, we combine the scenario two, that mean the cost and also the greenhouse gas reduction. We come up with the HRV implication. So here is the table to show the result. And we classify every scenario into different parameters like the energy use, the GHGI, the annual energy cost, and simple payback, and all the figures shown in the table. Let's jump to conclusion and recommendation. We took maximum greenhouse gas reduction approach finally, as it have a better benefit on the climate impact for the reliability of the building, and also it considered the future policy drivers. It helped on the economic benefit both on the operation and the returns. And final, it also considered the health and comfort of the occupants. So in this approach, we will deploy the heat pump water heater and also the HRV. Here is our SWOT analysis. For the strength, it can provide energy efficiency, environmental friendly, and also the comprehensive indoor climate control. For the weakness, we need to pay upfront cost is not less, it's pretty much, and also the installation complexity, and also we need to have a learning curve on the technology. For the opportunity, it have a long-term cost saving, and the there are still many government incentives upcoming to support our upfront cost investment, and also it is a market trend. For the threats, there's many leading edge competing technology, and we also need to have the perceived performance risk, and we cannot guarantee if our approach can meet with the regulatory trend in the future. So I hope we can do something aligned with the policy change in the future, of course, but it's not guaranteed. So that is all about our SWOT analysis and also about of my presentation. Thank you so much.